Greeting of the day. Myself, Rajesh, working as Assistant Professor in CSE Department, Madanapalli Institute of Technology and Sciences. Today, we have to discuss about Introduction to Data Structure. The definition of data structure is a storage that is used to store and organizing the data. It is a way of arranging data on a computer so that it can be accessed and updated efficiently. The data structure is not only used for organizing the data, it is also used for processing, retrieving, and storing the data. The definition of the data structure, we will give an example. While downloading the content from or the internet, the content will be divided into a number of types like images, audios, videos, document like. So all this data can be stored somewhere in the our mobile. It is going to be internal storage. So while accessing this content, we can use either image format or audio format or a video format. It means what is the data we have to store in our internal storage that can be used effectively and efficiently while using the retrieving also. So that is the definition of data structure. The classification of the data structure can be classified into two types. One is the primitive data structures and the second one is the non-primitive data structures. So first one, primitive data structures. Primitive data structures and non-primitive data structures. Primitive data structures are integers, float, character, and pointer. And non-primitive data structures are, it can be divided into further two types. One is a linked list, one is the linear list, and another is a non-linear list. So linear list means what are the operations we have to perform in sequentially, that is called linear list. And non-linear list means what are the operations we have to perform, that is in randomly. So examples of linear list is array, linked list, stack, queues. And examples of non-linear data structures are graphs and trees. So first one, primitive data structures. What is primitive data structures? Primitive data structures are the fundamental data types which are supported by a programming language. So it means some basic data types are integer, real, character, and boolean. The term data type, basic data type, and primitive data types are the often used interchangeably. The primitive data structures are usually writing in the programming language. If you write any programming language, we need some data types. The data types are integer, character, float, and boolean. So the character data type, it requires only 1 byte of memory. The integer data type, it is requires 2 bytes of memory. The float, it requires the 4 bytes of memory, and the double, it requires the 8 bytes of the memory. And next one is the non-primitive data structures. Non-primitive data structures are those data structures which are created using primitive data structures. So the non-primitive data structures are used to create the structures with the help of primitive data structures. Primitive data structures. Examples of such data structures include linked list, stacks, trees, and graphs. So non-primitive data structures further can be divided into two types. One is a linear data structure and second one is a non-linear data structures. And some of the operations is there. The most commonly operations on data structures are broadly categorized into create, selection, updating, searching, sorting, merging, and destroy or delete. Next one. First, the linear data structures are, first one is an array. So an array is the collection of similar data elements. These data elements have the same data type. It means while using an array, it can be only one kind of data type it is allowed. Either it is integer or character or float. The elements of the array are stored in the consecutive memory locations and are referenced by an index. The index starts from 0 to n minus 1. So in C, arrays are declared using the following syntaxes. One is the type, name, and size. This is the means what is the type of data type and what is the name of array, and we have to give the size of array. Now take the example. For example, integer is the data type, or marks is the array name, and size is the size of array is 10. The above statement declares the array of marks that contains the 10 elements. So from the above example, the array index starts from 0. As usually, the index, this means that the array marks will contain 10 elements in that array. The first element will be starts from marks 0, and second element starts with mark 1, and so on. Last will be going to be marks 9. So Next one, the array index starts from 0. That is graphically we can represent it from here. Arrays are generally used when we want to store large amount of similar data types only. So, but they having following limitations. Arrays are the fixed size. Fixed size means we cannot extend and we cannot decrease it. Data elements are stored in contiguous memory locations, which may not be always available. So insertion and deletion of elements can be problematic because of shifting elements from their positions while inserting elements one by one from here. So we have to perform deletion also. It can be sequentially, not randomly. So that is the major drawback in the arrays. And next, for example of an array, we have to use the for loop is there. So for I equals 0, I is less than or equals 9, I plus plus. It means we can start with array index I equals 0 and we will move up to I is less than 9. Every insertion we can move, I will be incremented. So scanf, what do we have to, where we have to start, that position we have to record of the array. So for example, writing an array for I equals to 0, I is less than or equals to 9, I plus plus. Every time while performing insertion, while performing searching, while performing deletion, we starts from array equals to I and array index equals to 0. So that is the array. Next one. So if we are reading or writing two-dimensional array, it would be required two loops. And similarly, the array of n dimensions would be required n loops. So some common operations performed on array. Not only in arrays, we have every data structure. We can use some operations like creation of an array, traversal of an array. So next, arrays are insertion a new element, deletion of required element, modification of an element, and merging of arrays. So if you want to insert an element into the array, we have to perform here. If you want to delete an element from the array, we have to perform sequentially. So if you want modification an element from the array, we have to perform sequentially. And we have to merging two arrays. It is the possible using arrays. The second one is list. A list is, in simple terms, is a linear collection of data elements. These data elements are called nodes. Here, every node contains two fields. One is the data field, and second one is the next field. The data field contains data, and next field contains address of the next node. The linked list is a data structure which in turn can be used to implement other data structures also. So the linked list data structure can be implemented in any data structure like trees, graphs, stacks, and queues also. So any data structure can be implemented by the linked list. So it acts as a building block to implement a data structure such as stacks, queues, and their variations. A linked list can be perceived as a train or a sequence of nodes. So we see the example in train. So the starting is the engine is there and number of bogies is there and last one is the last bogie. It is defined as the cross symbol. So it is same as the linked list start with the head and first node, second node, and last node contains null. It means this is the last node of the linked list, which node contains one or more data fields as a pointer, and already next we will discuss it in previously. Okay, next, the linked list can be divided into four types. One is a single linked list, second one is a double linked list, third one is the single circular linked list, and fourth one is the double circular linked list. As of now, already we know that a linked list. So first one we have to know about the head, the first node of the linked list. That is the first node. B is the second node. C is the third node, and D is the last node. The last node contains next field contains the null symbol. So it defines that is the last node of the linked list. So this is a linked list. Next one is a stack. The stack is also a linear data structure in which insertion and deletions both operations can be performed only one end, that is called top. So stack is called a last in first out structure because the last element which is added to the stack, that is the first element which is deleted from the stack. It means what is the element enter into the last one, that will be removed first. So in the computer memory, stack can be implemented using arrays or linked list also. Previously we discussed the linked list can be implemented any kind of data structures. So here also the stack can be implemented in the linked list also. So top is used to store the address of the topmost element of the stack. The top is the a variable. It is address of the topmost element of the stack. So it is the position from where we have to adding or where we have to deleting the element. So there is another variable, that is the maximum. So which is used to store the maximum number of elements that stack and stores. So before we have to insert an element into the stack, we can check if condition, if top equals to maximum minus 1. Whether the condition was true, then the stack is full. So then it will be occur the overflow condition. So that is it. And second one, if top equals to null, then it indicates then the stack is empty. If top equals to max minus, then the stack is full. Already we discussed that. So if the top equals to minus 1 means the stack is empty, then we cannot remove an element from the stack. So that is the underflow condition. So next, stack operations. The stack having different operations is there. One is push, second one is a pop, and third one is a pick, is empty, and is full. These are the operations we have to use in stack. First one, push. So push, to insert an element into the stack is called push. Second one, pop. To remove an element from the stack is called pop. The next one, peak. It will return the topmost element from the stack without deletion is called peak. Is empty. Is empty is a function to return the whether the stack is empty or not. And is full, it is a function, it will be written the stack is full or not. So we will see some examples is there. So first one, initially the top equals to minus 1 means the stack is empty. So after insertion of one element, the top will be increment. So every insertion, the top will be increment. So now after insertion of first element, the top position equals to 0. After insertion of second element, the top will be 1. After insertion of third element, the top will be 2. After insertion of fourth element, top will be 3. After insertion of fourth element, top will be 3. After insertion of fifth element, top will be 5. So while we have to insert a number of elements until we will get the stack is full. How to stack is full we will get? The top equals to maximum minus 1. Then we will get the top equals to maximum minus 1. Then we will get the stack is full. Otherwise, we have to insert n number of elements. So second one, so second one is the queues. So queue also a linear data structure. It will follows the first in first out data first in first out. So which element is that is inserted first, that will be removed first. The element is a queue that are added at one end. The elements are queue added at one end, that is called rar, and remove from another end is called front. So like stacks queues can be implemented using either arrays and linked list. In previously we discussed it. Every queue has a front and a rar variables that point to the position from where deletion and insertion can be done respectively. So already we discussed it. We have to insert elements at one end, that is called rar. We have to remove elements from the queue, it is another end, it is called front. So now every insertion rar will be decrement, every deletion front will be increment. The basic operations are used in queues are NQ. NQ means to insert an element into the queue from rar end is called NQ. DQ. So DQ means to remove an element from the front end is called DQ. Peaks. It will return the topmost front element from the queue. And empty checks if the queue is empty or not. And full, so define the whether the queue is full or not. So this is the queue operations. So next, queue, a new person comes, and examples of queues are new person comes and stands at the end of the row, and a person getting their reservation confirmed get out the row from the front end. So for example, while taking the example of queues, while we going to the movie theater, movies ticket reservation center, or anywhere. So here we can perform first come first serve based. So while entering the reservation, who are the stand first one, they will serve get the first one. So this is the example for queues. And queues are implemented two ways. One is arrays and second one is the linked list. Next one, non-linear data structures. Nonlinear data structures examples are trees. So tree is a nonlinear data structure which consists of a collection of nodes arranged in the hierarchical order. So one of the node is designated as the root node, and the remaining nodes can be partitioned into disjoint sets such that each set is a subtree of the root. It means the topmost element is considered as a root, and remaining all are going to be subtrees of the that root node. So the simplest form of tree is a binary tree. So binary trees consist of root node and left and right subtrees, where both subtrees are also binary trees. So here I will give you a definition of a tree, and tree is contains one root and number of children. The tree can be differed from the binary tree. The binary tree having the only one root and it having the two children only. The tree having the n number of children. That is the difference between trees and binary trees. The binary means 0 or 1. It means the binary tree contains 0 children or 1 children, at most 2 children. So that is the differ from the trees. So each node contains a data element, a left pointer which points to the left subtree, and a right pointer which points to the right subtree. The root element is the topmost node which is pointed by a root pointer. If root equals to null, then the tree is empty. Now we'll see the example of the a tree. The P is the a root element because of it is the topmost element. The root element having some subroot is there. So Q and R the subroots of the root P. So and Q A and B are the child of Q, C and R D of the child of R. So here L is the parent of the E, F and G, and M is the parent of H and I. So here leaf node is there. Leaf node means leaf node doesn't have any child. So this is the tree structure, and next one is the graphs. So graph also a nonlinear data structure which is a collection of vertices and edges that connect these vertices. So graph is often used as a generalization of the tree structure, where instead of purely parent to child relationship between tree nodes, any kind of complex relationship between the nodes exist. An edge connects to pair of vertices and may have weight such as length, cost, and another measuring instrument for according to the graph. Vertices on the graph are shown as point or circle, and edges are drawn as arcs or line segment. So now we will see some examples of graphs here. Here one is a directed graph is there, and another one is a undirected graph is there. So directed graph means one node to one node having some direction is there, and undirected means there is no direction. It will be considered as a v1 and v2. So v1 v2 is a one edge, and v2 v1 has the another edge. It because there is no direction from going to be directed graph. So it having the direction v2 to v5. It is the edge is v2 v5, but it should not be v5 to v2, and it having some weight. So the v2 to v5 edge having weight is 6. So these are the examples of some graphs, and types of graphs are directed graphs, undirected graph, simple graph, weighted graph, a connected graph, and non-connected graph. These are the types of graphs. And what basic operations? The basic operations are performed by data structures. The section discussed on different operations that can be performed on various data structures previously mentioned. One is traversing. So traversing means access each and every data element in exactly once only, that it can be processed. For example, to print the names of all the students in class, we have to only access only once. That is the meaning of traversing. Searching. So searching means to find. It is used to find the location of one or more data items that satisfy the given constraint. Such a data item may or may not be present in the given collection of data items. So for example, to find the names of all the students who secured 100 marks in the mathematics, it means whether the element was available or not available, whatever it may be, we have to perform searching element. If the element is available, the searching is completed. If the element was not found, searching is completed but unsuccessful. That is the searching operation. And inserting operation, it is used to add a new data element into the structure. It is the given list of data items. For example, adding to the details of new student who has recently joined in the course. So it means to add the element into the structure. And second one, deleting. It means to remove an element from the structure. So it means the particular data item from the given collection of data items, we have to remove it. For example, to delete the name of student who has left the course. So this is a deletion operation. Next, sorting. So sorting, data items can be arranged in order. Either it is be ascending order or descending order. So depending on the type of application. For example, arranging the name of the students in the classroom in alphabetical order, or calculating the top three winners by arranging the participants' scores are depending order the extracting the top three. That is another operation. And last one is the merging. So merging means concatenation. The list of two sorted data items can be combined to form a single list of a sorted data items. This is the operations of data structures. And these are the references we have to use in previously. And thank you.